Hi everyone, welcome back to the channel. Today I'm going to try to predict stock market for next day. So basically the price of the next day using ADA Boost. So I'll be using this regressor to figure out what can be the price for the next day, and the inputs that I will be taking will be open, high and low. So let's start. So first thing is obviously we have to import the libraries. So I'll be importing all the libraries that we require. Pandas, NumPy. We'll require the metrics from sklearn, matplotlib, then I'll be taking all the sklearn models. I would require the R square score, the mean squared error, and the mean absolute error. This will tell us whether the results that we are getting are good enough or not. I will need the ensemble ADA boost regressor model to be imported. I would need the confusion matrix. Let me just add it if in case I require it. And the accuracy score. I'll just cancel. I'll just close all the warnings. So warnings dot filter warnings, and I'll just make it ignore. Okay, I think we are done with all the inputs. So I already have the daily data. So I'll just be reading that daily data now. It's nifty daily data. I'll show you how the data looks like. Just parsing the dates. So this is how the data looks like. It has the dates. It has the OHLC, because we'll be requiring this. And what I'll do is I'll just change the format, the date time format. So df.index. Let us check if it's right. Yeah, it's fine. So let's start. So as I said, we will be requiring our features. So the features is the open, high and low, assuming we have this as the features, and the target can be close. Again, you can do changes. You can make features as previous close also. You can test it out with different ideas. And the next thing we want to do is we want to split the data into train and split. So x is equal to data frame of features, and y is equal to data frame of target, and x train comma x test, y train comma y test is equal to train underscore test underscore split. So I'm just splitting my data into test and train. So this is a general format we use every time, and let me use the test size of 30%. And I'm just saving the random state so that you can check it and match if you're doing it at your end also. So let me just print it out to see how it's looking, how the shape is coming along. Yeah, it looks, one second. Okay, not the X train, is the X test. Yeah, it's fine. So Now let's plot the data. So I'm going to plot the data now. So the training part is df.log, and I've already calculated it's all the data before the 01/01/2021, and the test data is df.log. All the data after this. Okay, and let's now just try to plot it. So figure ax is equal to plt dot subplots, fig size is equal to, let's say, 15,5. I'm first plotting the training part, ax, and the label is training set, and test dot plot, ax is equal to ax, label is equal to test set. And I'm just going to make a line so that we can see the colors separately. Okay, that should do it. I think ax dot legend, I'll just plot the legend also. So train comma test. Okay, let's see if it works. There seems to be some issue. Let me check. Okay, lock. All right, so we have got this. I think there is still some error. Let me check what the error is. Okay, not a v line, axv line. 2021, and there we go. So we have got the split of the data, the training data and the test data. So now what we're going to do is we're going to run the AdaBoost regressor. So I'm just actually going to do the regression now. So regressor is equal to AdaBoost regressor, and we have to put the hyper parameters. So let me put the initial parameter as, let's say, 50. I'll change the learning rate, which has a default value of 1, to, let's say, 0.1. So these are all the hyper parameters. You can go through what does each hyper parameter do. Okay, and let's just regressor. Let's just fit it now on our training data set. So we've got, let's see if it runs fine. Okay, there is some issue, the learning rate. Okay, this is not learn rate, learning rate. Right, so we have got our regression done. Let's predict the values now. So y predict is equal to regressor dot predict, and we have been able to predict now. So this should predict. So what we have to do is now evaluate the performance. So let's evaluate the performance first on the test data, on the trained data itself. So let's see how it works on the training data. Then I'll see it on the testing data also. So predict is equal to regressor dot predict x dot train. So this is the train. R square is equal to R2 underscore score, and this is between y train and the predicted value. So whatever is the predicted value based on the training data set, I am comparing it to the actual value that we have put in the y train. Let's also put the MSE, which is the mean squared error, again between the y train and the predicted value. Similarly, let's put the RMSE, which is the root mean squared error. So which is mean underscore squared underscore error y underscore train predict, and I think this is how it's done. And let's find out the MAE, which is the mean absolute error. Basically this will tell us what is the actual error, absolute error per day of the predicted value, um, and the actual value. I think this should give us good indication whether the results are good or not. So let's print it out. So the R2 is R2, MSE is MSE. So let me just copy it quickly. RMSE, and the MAE is MAE. So that should give us the result. Let's see. Okay, there seems to be some issue here. R2 score, it's not able to print it somehow. Print R2. What is the error? Let me check. Predict. This is the issue. Let's run it again. And we've got the results, and the results look pretty bad actually. The results look pretty bad. As you can see, the MAE, the mean absolute error, is 187. That means on average the result, the and this is on training data set. So on average the predicted data is about 187 points away from the actual data. So it's actually pretty bad. Let's just run it on the test data also. So I'm just going to copy it here. Let's do it on the test data just to see how it works on the test data. And now I would not be requiring this, and wherever I've used predict, I'll just use the ypred. So I'm just putting ypred everywhere. Okay, let's run it now. Okay, where did I make a mistake? Let me check. Let's check what's the issue. Ypred is a regressor dot predict x underscore test. This seems to be fine. Oh, this is not white train. Now this we are testing it against the testing data. So this is white test now. So the shape was not matching. So it should give us the error now. Okay. So as you can see, the results are equally bad. It's the mean absolute error is 194. So it's actually not giving us great results. Anyway, so let's try to plot it just to see how it looks like. So prediction for the data, we can use test OHL of features, and then y underscore ypred is equal to regressor dot. This is required in case you want to predict any of the data, in case you want to do that. So let's plot it out. So I'm going to plot the results now. So plt dot rc params, figure dot fig size is equal to 20, 10. plt dot plot, first the test index with the test target, and let me put the color as red, and this is the actual data, and then I'll be using the predicted data now. So I will be now using the predicted data after this. So test index ypred, color, let's say it's blue, and this is the predicted data. And let's now just put the title, which is the NS Nifty stock price, plt.x label. We are plotting days, and in the Y we are plotting the prices, the close price actually. let's show the legend and let's show the plot, right? And of course, look, it's going to be pretty bad. Okay, I made a mistake here, and as you can see, the results are not good. The blue line is the predicted line, and it's not actually giving great results, which we already saw here. So let's try to do something. Let me try to change the learning rate from, let's say, 0.1 to 1, and maybe increase the estimators to 100. If we do this, so just remember what is the current MAE, that's about 187. Let's try to reduce it. So I've just changed the parameters, the hyperparameters, and it has gone down to 81. So the chart should look better now. So just remember the chart. I'm going to well, actually what I'll do is let me copy paste it and run it now. So you can see here that the results are definitely better now, but still ADA boost is not able to do what we're trying to do. So probably this is not a great regressor for predicting stock prices, or maybe we need to put more inputs. But anyway, this is how you use ADA boost regressor. Obviously the results will depend on the hyperparameters, so go through them, learn it, and understand what each hyperparameter means, and then you can play with it. Our main aim should be to reduce the MAE. So I hope you enjoyed today's video, and I'll see you next time. Thank you.